Hey everybody, I'm back to tell you about a few different things that NitroNet also offers that I haven't talked about yet. Um, to begin, I'm going to start with a background on how exactly packets are sent over TCP, UDP, and HTTP, and how there's security behind that to make sure that your packets aren't being intercepted by third-party applications, values are changed, things like that, and also looked at. Because they can be big security holes when it comes down to those things. Um, so when a packet's first sent over a network, there's going to be some background information, some technical information, I guess you would say. You don't have to understand all of it. I'm just going to give you the background in case you want to know. When a packet's sent over a network, it's broken down into bytes, an array of bytes, which are just values between 0 and 256 that represent the object itself, where when you put those back together, you can send them back through a stream to recreate the object. That's how a packet is sent over. That's how an object is sent over a stream. And that serializable interface that we implement um, for all of our packets are what allow it to be broken down into bytes. If it's not serializable, it can't be broken down, and therefore it can't be sent over. That's why you have to implement that. Um, so now, whenever a packet is sent over, it does some different insertions into the actual byte array before it's sent over to the opposite side. Um, so, for example, one of the things that NitroNet supports is packet corruption handling. So this pretty much means that if a packet is ever modified through third-party applications, values are changed that it shouldn't be, or something happens to it, the packet's not completely received, something like that, where in that case it would be a risk to your application. Excuse me. NitroNet makes sure this doesn't happen. And the way that it works is um, every single object before it's sent over is given a checksum. And what a checksum is it's just a value that represents the object, and it's unique to every object. And it won't change. Say like say I start a project, get the checksum, end the project. When I start that same project up and I get to check some of the object again, it'll be the same exact thing. It doesn't matter where it's run, what project it's run under. There's no changing to it. All it really does is it creates a value based off of the internals of the object itself. A chat message with the message of hello will be the checksum of that will be different than the checksum of a chat message's value with how are you. They won't be the exact same thing. So now if you think about it, say that I send over a message that says hello in the chat message, and somebody edits that message before it actually reaches the other end. When that message is edited, I can't even say it right, it will change the checksum after that edit because he might have changed the value to how are you instead. So when it's received on the opposite side, what it does is it gets the checksum that was originally sent from the client side. So it gets the original checksum and compares it to the checksum of what was received. Now, if those two checksums don't match up, it means that the value or the object was changed at some point, and it'll actually ignore that packet and it won't let it be processed because it's a security hole. If say for example you have a packet that has a variable that says whether or not you're an administrator on the server. Say it's set to false for every single user, and say that someone changes it to true using a third-party application. This is a huge security hole, but it will be prevented from the checksum packet corruption handling because it'll notice that something was changed and it won't let that go through. So that's where it becomes important to just kind of know that you're going to be protected when you're sending packets over stream. That's one of the things that NitroNet does that not many other libraries offer. I know that CryoNet definitely doesn't offer that, and also Netty doesn't. These are things that you would have to implement yourself, but would be a pain in the butt to do. It did take me, I mean, I've been working on this project for probably 10 months now, so I have a lot of experience with it. It's very optimized, has a lot of different features, stable features, and this is just one of them. On top of that, away from the checksum portion, I also implemented the ability to encrypt and decrypt packets. So you'll be able to take the bytes of data that are being sent over the network and encrypt them how you'd like to be. So that way, like again, if somebody would be trying to edit edit the packet using a third-party application, they would see encrypted numbers. So I'm actually going to show you how to do that on the client. It's very easy to set up. Once again, I wanted it to be very easy to use and very dynamic. So we're actually going to do that right now. So I'm going to create a new package, and it's just going to be called Encryption. And we're going to create a new class. We're going to call it my encryptor. Oops. I mean, you can call it whatever you want, but that's what I'm going to call it. And any encryption, any class you want to be an encryptor to encrypt and decrypt data has to implement the encryptor interface. And what this does is it gives you two methods, encrypt and decrypt, which are super self-explanatory. Now, by default, you can just return, it's going to return the data back. So by default, say you don't want to have any encryption, you just send back the data. It's just kind of like a pass-through encryptor and decryptor. It doesn't do anything to the data and it won't change it at all. Now we're just going to set that there for now, and I'm just going to show you that it will run correctly. So on the client and server side, you need to make sure that the encrypting and decrypting is the same. Otherwise, if you encrypt something and it doesn't decrypt, it's not going to be able to recreate the message because it's encrypted. And I'll show you an example of that as well. But to get started, we want to set the encryptor to the client and the server. So all you have to do is just do client.set encryption method, and we're set an instance of my encryptor. Easy as that, just like it is to the listener. So we imported my encryptor and it's there. So now we're going to go to the server side, and I'm using the chat application from the last video if you don't recognize it as well. And you can get it off the GitHub. I'm going to go to the server. I'm going to do server.set encryption method new my encryptor. And now we're just going to run them like normal. Server starter, we're going to start that and start the client. And it's going to be just like anything else. Everything's going to run correctly. Hello, hello. Nothing's changed at all. So just the pass-through encryptor doesn't do anything to it because all we're doing is just returning the data. Now, say that we want to do something with the data. We want to encrypt it, right? So we're going to go to the encrypt method or make a very basic encryption. I'm not going to do anything too crazy. I mean, there's tons of methods online that you can use to encrypt your data, special ways you can make your own encryption methods, whatever you want to do. I'm just going to change the value by incrementing each value of each byte by 1. So all we have to do is just go through each piece of data and encrypt it. So we're going to do for int I, which equals 0, which is less than the data.length. So we're going to go through every single byte in the array. We're just going to do data of I, so the value, that byte value at that location is just going to plus equal 1, and it's going to encrypt it. Now, just like we encrypt something, we have to decrypt it. Otherwise, it will not receive and won't create the object because it's encrypted. There's a value of 1 added to it, so it's not going to work. And I'll show you that right now. Where if I start the server and I start the client, it's going to encrypt it by 1 on the client and the server, and that's going to try and decrypt it, but it's not going to work. So you'll see blah, 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 concurrent modification error, invalid stream header. It's just going to be like that like crazy. So if somebody would change it, this client's just going to disconnect. It's not going to work. So you'll see it disconnected. Excuse me. So that's how that works. It's not going to work. So after that, you'll even see it on the client side. After that, what we're going to do is we're just going to want to decrypt it by 1. So we're encrypting it by 1. So when we want to get it back to the normal data, we have to decrypt it by 1. So we're just going to set it to minus equals and then return the data. So now if we run it, it will work exactly the same as you saw it when we ran it the first time. But in the background, it doesn't tell you this, but in the background, if you would go through the source code and you would debug it and you would see the bytes, you can actually see the bytes changing. So they would all increment by 1, and then when they receive the data, they would decrement by 1. So that's how the encryptor works. It's very, very easy to set up and use. You can go crazy with it, do whatever you want with it, modify your packets how you'd like to. Now there's also an important thing. I just want to kind of go over like the settings of the client as well. Since we're on the topic of actual bytes and byte arrays and how it actually works. When an object is sent over a stream, it has to be set to a certain length, a certain buffer size, and you can change this as you need to. So say that we break down the client, or we break down an object and it's 5,000 bytes. We would need a buffer size of at least 5,000 to be able to send that over the stream. So by default, the buffer size is equal to 2048 on both the client and server side. So if we try and send something bigger than that, it's not going to work. It's going to crash because it's not bigger than that. So if you want to send big objects, you have to actually go to the config options and change it. So we'll get the config from the client, and we will set the packet buffer size to whatever we want. Now the max size that TCP can send over max bytes that it can send over is 64,000, which you might think is a lot, but when it comes down to big applications, big objects, like for example, just trying to send over a picture, bytes of a picture, that can be, depending on the resolution, millions of bytes. So it will not send, and I'll give you a solution to that problem in our next video, actually. Um, but all you have to do is just change the packet buffer size, and it will make it so you can send bigger objects up to that size. Now, when you set it to 1, I recommend setting it to the other. Otherwise, it's just not. It can cause problems in the future that you may not want to um, have. So you can set them on both sides just by setting the server get config to put the same. That'll set that correctly. So that's just kind of the background information on what's happening in NitroNet instead of just the front end, but it's also how to encrypt the bytes that are being sent over the stream. So in the next video, I will go over something that I call complex objects. That's what I have NitroNet referred to it as, but it's really just a method of packet streaming, and I'll go over that in the next video. So stick around. That's just another feature that I'm ready to show you guys how to use, and I hope you liked the video. So I'll see you soon, guys.